Right now, there are only three things limiting how far our spacecrafts can take us in the universe: the resources we devote to it, the constraints of our existing technology, and the laws of physics. If we were willing to devote more resources to it as a society, we have the technological know-how right now to take human beings to any of the known planets or moons within the solar system, but not to any objects in the Oort cloud or beyond. Crewed space travel to another star system, at least with the technology we have today, is still a dream for future generations. But if we could develop superior technology, nuclear-powered rockets, fusion technology, matter-antimatter annihilation, or even dark matter-based fuel, the only limits would be the laws of physics. Sure, if physics works as we understand it today, traversable wormholes might not be in the cards. We might not be able to fold space or achieve warp drive. And the limitations of Einstein's relativity, preventing us from teleporting or traveling faster than light, might not ever be overcome. Even without invoking any new physics, we'd be able to travel surprisingly far in the universe, reaching any object presently less than 18 billion light-years away. Here's how we'd get there. When we take a look at conventional rockets that we launch from Earth, it surprises most people to learn that they barely accelerate more rapidly than gravity accelerates us here on Earth. If we were to jump or drop from a high altitude, Earth's gravity would accelerate us towards our planet's center at 9.8 meters per square second, 32 feet per square second. For every second that passes by while we're in free fall, so long as we neglect outside forces like air resistance, our speed increases in the downward direction by an additional 9.8 meters per second, 32 feet per second. The acceleration that we experience due to Earth's gravity is known as 1 gram, pronounced 1g, which exerts a force on all objects equal to our mass times that acceleration, Newton's famous F equals ma. What makes our rockets so special is not that they accelerate at approximately this rate, as many objects like cars, bullets, railguns, and even roller coasters frequently and easily surpass it. Rather, rockets are special because they sustain this acceleration for long periods of time in the same direction, enabling us to break the bonds of gravity and achieve escape velocity from Earth. One of the greatest challenges facing human beings who wish to take long-term journeys in space is the biological effects of not having Earth's gravity. Earth's gravity is required for healthy development and maintenance of a human body, with our bodily functions literally failing us if we spend too long in space.